Welcome back. Now we're looking at section 4.2 from the text, solving systems of equations by substitution. So to do this, you have two equations. You solve one equation for one variable, either x or y. Substitute that expression into the other equation. Solve for the remaining variable. Then you'll substitute that value into one of the equations to find the other value and state the solution. So again, you need to solve one equation for one variable. It doesn't have to be y, it could be x. Then whatever that expression is for the variable, you substitute it into the other equation. Solve for the remaining variable, and then substitute that value into one of the equations to find the other value and state the solution. So let's see what you can do with this example. I'm going to need more space, so I'm going to erase the board. How's it going there? I hope you're doing well. Keep at it. And then we'll look at this together. So let's see what we can do. So when you look at this system, you should notice that the top equation is already solved for x. So that is going to make our life much easier. I'm going to circle that equation, and I'm going to make a note of where x is in the other equation. So that equation is solved for x, and I'm going to substitute for x into the other equation in that position. So instead of 3x minus 7y, it's going to be 3 times our new value for x minus 7y is negative 28. So it's going to be 3 times our new value for x. And our new value for x is going to be the expression 5y minus 4. And notice I used parentheses so that the 3 is multiplied by both values in that expression. So now we're going to distribute the 3. 3 times 5y is 15y. 3 times 4 is 12. At that point, on the left-hand side of the equation, you see that 15y and minus 7y can be combined. 15y minus 7y is 8y. And then the inverse of subtraction is addition. So you'll have 8y is, the signs are different, so you subtract and take the sign of the larger digit, which is negative, and then you will divide both sides by positive 8. And you'll have y is negative 2. Are we done? Of course not, because at this point all we have is y, and we need to go back and find x. And I like to use the circled equation. To me, that's the easiest one to use. So I'm going to take the circled equation, x is 5y minus 4, and I'm going to make my substitution for y. So x is 5 times negative 2 minus 4. 5 times negative 2 is negative 10. Negative 10 minus 4 The signs are the same, so I get negative 14. So our solution for the system, x is negative 14, y is negative 2. And I'm going to put that in curly brackets to indicate that it is a solution. Now, at this point, we're done. We really should check to make sure that this is indeed the solution. So, the first equation, x minus 5y is negative 4. Remember, this is x and this is y. Is x equal to negative 5 times y minus 4? Negative 14 equals negative 14, and that checks out. So that's equation 1. We can also check equation 2. This is not mandatory, but it's good to make sure your answer is correct. The other equation would be 3 times x minus 7 times y, and we want to see if that's going to equal negative 28. It's a question until we do this. So negative 42, two negatives make this a positive 14. And when you add numbers with different signs, you subtract and get negative 28. So that indeed holds true as well. So this is our solution, negative 14, negative 2. And that solution holds because we checked it and it has to work in both equations. Thank you.